On example 17, we're going to first check to see if the denominators are the same. They are not, so we have to set the fractions up using the least common multiple. Well, these both look like they're in their factored forms already, and there's nothing that's in common, so whenever that happens, you're just going to multiply each of the other fractions by the denominator of the other fraction. So we're going to multiply the second fraction by 6 n squared times n minus 1. You have to do it to both the numerator and the denominator for it to be correct, because we are multiplied by 1, actually. And then the first fraction, we're going to be multiplying by n plus 5. So go ahead and multiply those out. Leave the denominator in the factored form. From here, you're going to want to multiply out the numerator and combine like terms to see if there's anything we can factor up there. So go ahead and distribute the 9n squared into both terms. So then you'll get 4n plus 20 plus 9n to the third power minus 9n squared. And then it's all over the same denominator we've been writing. 6n to the second power, parentheses, n minus 1, close parentheses, times, open parentheses, n plus 5, close parentheses. So go ahead and reorder these top terms to make them so that the n cubed is first, because it's the one with the biggest exponent. That's your leading degree, your leading term. Okay, so from here we're going to see if we can factor anything up there. Well, let's go ahead and try factor by grouping. These first two terms both have a 9 and an n squared, and then we're left with n minus 1. If we take the second two terms, we can take out 4, and we're left with n plus 5. Now, it looks like there's nothing you can factor any further from here, so nothing's going to cancel out, so you're not going to get any wholes. So we're done with that step. So for vertical asymptotes, we just set the denominator equal to 0. So n squared equals 0 when n equals 0. So that means we have a vertical asymptote at n equals 0. That's one of our excluded values. When we set n minus 1 equal to 0, we would get that n is equal to 1. So we also have a vertical asymptote at n equals 1. And then the last part, when we set n plus 5 equal to 0, we're going to get n equals negative 5. So we have vertical asymptotes at n equals 0, 1, and negative 5. So those are excluded values. So that is going to be our answer. This is our reduced form with our excluded values here.